Hi, so I just wanted to show an example of what the S2 command line interface looks like. So if you have a S2 authentication token, which you can get from the dashboard, you just need to provide that either through S2 config or you can also set this environment variable. And basically, once you have that, you're up and running. So with LS, you can list the different basins within your account. We could create a new basin. Maybe I want a bunch of streams containing features for users on my site, shops on my site, something like that. So we can just work with that pattern. And I will copy this. So basin is created. And then within that basin, we can start creating streams. So streams are completely unlimited. They're provisioned immediately, so it's pretty easy. So I will create a stream. And maybe we'll start with shop. And this will be the 0th shop. And we can see it exists there. By default, streams are provisioned in the express storage class, but that is configurable. You can see under help. And you can also set a retention policy. So if you want records to automatically get deleted after a certain amount of time, we could configure that. And as I was saying, streams are completely unlimited, so we can do things like have one stream per user. I will make 500 just to start. So using sequential user IDs, piping it into a parallel invocation of create stream, we're just going to make user 0 to 499. Great, that's finished. So, whoops. Here we can see all of our new user streams, and we can also filter just by prefix. So if we just want to see the ones starting with 00, it's easy enough to do that. And I'm just going to pick one and start a streaming append session on it. So by default in the command line interface, if you start an append session, it's just going to interpret new lines as records, and it'll be sending records in UTF-8. So we can also, over here on a different terminal, start a read session from this same stream that we're appending to over on the left. And we've immediately caught up, read all of the records that exist in the stream, and have automatically entered a tailing stream. So we're just consuming from the tail of this stream. And if we go back over here, you can see the records actually flowing in real time to the reader. So over here on the append side, you can see after we issue an append, we get an acknowledgement back. Acknowledgements only happen once a write is actually made durable within a region, and similar for delivering that record to any consuming readers. That's only done once it actually becomes durable. I'll stop this read session, and you can also see that we can consume starting at any sequence number. So I'll start at the first one or the third one, whatever. We can also check the current tail of the stream. So this basically just gives us the sequence number which will be assigned next. So when we do something here, this one should receive the sequence number of 4. That's all that means. So the command line interface also has a ping utility. I'll use a different stream for this. But basically, this is just a simple way of testing end-to-end latencies and also acknowledgement latency. So this will send some random records and basically compute some statistics about how long it takes for each append to be acknowledged, which is just for us to receive the receipt that it became durable, and also end-to-end latency, which is how long it takes for a tailing reader to receive the record that we just appended. And you can actually see in this case, the latencies are almost identical. which is a little bit surprising, but actually makes sense if you think that the reads are tailing. So it doesn't actually take that much longer to deliver a full record to one of these readers versus a receipt back to the appender. So another neat thing that we can try out is just check out the actual append throughput, which is allowed for a single stream. This is not a functionality of the command line interface. This is just an internal tool that we have, but you're free to create your own version of this if you're so inclined. But essentially what this will do is just create a bunch of random records similar to the ping, but actually try to send it at a configured rate. So we start throttling appends at around 125 megabytes per second. So this is going to try to write just a little bit higher than that. Actually, we'll make this 200 per second just to actually see the throttling effect. And it'll construct records with an average batch size of 10 kilobytes, which is also configurable. And, I think. All right, so this is a little bit difficult to read. I'll make this bigger. But essentially what we want to look at is the emitted bytes within the previous second. So you can see we quickly got to this sort of stable point around 125 megabytes per second. And we are indeed appending at that rate. So I think if we check this, yeah, we can see that we're actually transmitting at around 125, 128 megabytes per second. And this is at a single stream, so a single ordered stream. If we wanted to, we could start this across multiple streams and completely saturate our connection. But it's just a cool thing to check out.